Hello, good evening, welcome back. Welcome back to the lab, to the workshop, to the little desk of green, and another Erica Synths DIY kit to put together. After our wranglings last night, where we breadboarded the heck out of the thing, it was good. It was good. I really felt that I grew through it. There was, there was a lot of stuff to pack on the breadboard, but the development of it was really interesting. The whole idea of taking this square wave, which you then you push out the front and you push out the back, using, I can't remember. Well, we used a couple of pots and we used a capacitor in between. We started off with one pot which did the whole lot, and then two, and then eventually we got to three to put in this sustain stage, which also acts as well, there's kind of a combined attack, sustain, release, decay. Oh god, this is, I don't know, what am I talking about? Well, I think what I'm saying is that we took that envelope through various stages, which was really good. I like the way that that Moritz does that in the documentation. I think that's a particular strength of what's going on here, is that you start with something quite small on your breadboard, and then it gets more complicated and it gets more difficult and it gets harder to see, but slowly things are beginning to reveal themselves to you. It's very, very interesting. We got as far as getting the LED to light and to glow in the way that the envelope was opening and shutting. So that was very exciting. We didn't get to look at the inverting or the looping because we just ran out of time. There wasn't enough time, but all of it was good stuff. And I think we got to the point that we needed to get to, and the looping and inverting are cool, and it's all there in the documentation and you can look at that. But I'm not going to go into any more depth on that now. We're going to get straight on with the soldering side, because that can take long enough by itself, right? So that is where we got to, and this is the breadboard where we ended up. So I'm going to pull all this apart, and then we can get on with the business of soldering. Get my glasses off. Can't see anything here. Good to see you. Hi, how you doing? Ken, always a pleasure. Ian, great to see you here. MPC, X modular. A bit of a groove modular, hey? You're very welcome. Neil, hi. Searched, hello. Yes, indeed. Good, thanks for coming. I kind of think I sprang this on people a little bit, because although I put the link up to this yesterday or last night, I hadn't really told anybody, so I'm sorry about that if there's only a few of us. But this is probably the one which is easier to do later, because there's probably less discussion in this, in trying to work things out. This is much more of a, this is how we're going to do this. And so, oh, Holger, hey, thanks again. Yes, I'll try my best to stay focused. So that's the plan for this evening. I'll take this apart, follow the instructions, try not to get in a mess. It doesn't look too hard as it goes. Doesn't look too hard. Might say that though. There's always something that gets us in a knot. Right, let me see if I can get my soldering iron on. Would be good. I think that's a good start. Turn that fella on. That's not going to melt anything where it is. Don't think so. No. Good. So let's go to now. I'm not going to look this time. No, damn it, I am. Yeah, no, that was the right one. Okay, bring that in here. Let's just adjust this a little bit so we can see what we're doing. So this was our breadboard. Let's sadly put all this apart. There was one interesting thing just to highlight as I'm putting this apart, was that it felt back to front, because we were putting input in on this side and output over here. And it's really weird how you become accustomed to a certain way of doing things. I'm very much a left to right modular person. That just seems to be how it goes. I tend to fill a case from left to right. I tend to patch from left to right. Synth voice left to right. Inputs on the left, outputs on the right. you know, that's just how I go. So when this is the other way around, it's really interesting how I felt kind of thrown to some degree. It took a little bit of brain power to work out what the heck was going on. Now I might leave those in for the moment because it might help me pick them back up better, easier, without losing track of what they all are. If you're with me. Blue torch. Increasing temperature. I'm back up to 380. I went down for 350 for a while, but 380 was where I had been until I changed it at the request of Dreadbox. So I think 380 is where I like to be. I'm gonna go with that if that's all right. Are you all right? Oh yeah, I see what you're saying, Ian. Yeah, bit of a low pass filter. I guess that's kind of what that is. Everything is related, isn't it? Ultimately, right. So let's get to the right place on the manual then, and we can see what it is we have to do. That's all unimportant. Don't contact me right now. I am live streaming, don't you know? Status LED, that's what we got to, yeah. So the build part is actually the smallest part of the manual, which is probably how it should be. Lots of really good things to learn in here. Okay, build guide, here we go. Module assembly appendix. Right, this is where it all goes a bit pear-shaped, but we're going to give it a go. Let's cut to our overhead. No, to the manual. That's what we're doing. Manual. What's going on? Yeah, okay, good. Right. So before we start, it says, have a look at the complete envelope schematic on the next page. Okay, schematics. Let's have a look at that. So we're not going to read that yet. We're going to have a look at this and see whether we can see or remember anything from last time, from yesterday, that we can spot on here. Oh, excuse me, I have just had my tea. So, so this was a high pass filter to get the 12 volt boost. Does that make sense? I think that's what that is. Now you're probably not seeing that. Let me use my mouse rather than my finger. So this bit here, this I think was a low pass filter. So the stuff comes in because we're just trying to give it a burst which triggers this and triggers this at the same time. Part of this goes to the sustain section, which is actually, look down here, it's labeled sustain, and the other bit goes straight on through as the envelope normal. So this bit here, this sustain section, is sort of triggered at the same time as the whole envelope is triggered, so that as you get the attack voltage going up, as it then comes down, it rests on that sustain level, which we set on the pot. So that's how we get our sustain sections. It's not a true ADSR. It's kind of a fiddle of fudge, a flamdammering within what envelopes can do. There's the loop switch, which lets that whole thing just happen again and again. So when it gets to the end of the sustain or the end of the attack or something, anyway, it loops. We'll work that bit out later. Then we have this whole section in here, which does our attack and release sort of sculpting of that voltage. That's cool. There's an optional thing there. That's interesting. Don't remember what that is. That's something to do with stopping something going. Is that? Well, it's evidently some kind of feedback. I don't know that I completely remember. I was doing so well though, I thought. The transistor over here does the LED. And then we've got something, and then we've got this extra circuit here to do the inverted outputs. So that's what it's got. Can't quite remember every bit, but I don't think I was too far off. I don't think I was too far off. Now, are we back? Yep, so let's go back up to what it was trying to tell us about building stuff. So we had a look at the schematic. Okay, things are called things. The XS1 is the gate input jack socket. XS2 is the envelope signal output. Three is the inverted output. Yeah, good, good. XP1 is a standard power connector. Yeah, we've got that. No problem. VD2 and 3 are the stock key diodes, which are these big fat ones. They double secure the reverse polarity. So that's what those are for. Next we have 10 ohm resistors with decoupling or bypass capacitors. These capacitors serve as energy reservoirs that keep the module's internal supply voltages stable. Always a bit of that going on in case there are any fluctuations in the power supply. A combination of R5 and I6 and a large microfarad, 47 microfarad pair of C2 and C3 compensates for low frequency fluctuations. So all of that business is to do with the power. So the power itself is not just a connector, it also needs diodes and capacitors and other bits and pieces to keep it all nice and good. The other component is a ferrite bead. Oh no! Did I see a ferrite bead? Is used instead of a 10 ohm resistor. You know what, I think we've got a 10 ohm resistor. We do. So I don't think we have. I haven't spotted. I didn't see. I don't remember seeing a ferrite bead. I'm not going to worry about that for the moment. Often, okay, often another component, a ferrite bead is used. Okay, but that's not what we're doing here. Good, good. Read all the text. Another advantage of 10 ohm resistors is that they act like a slow fuse. That's helpful. Good. Capacitors C6 to C13 are additional decoupling capacitors. If you inspect the PCB, you'll see these are placed close to the power supply pins. So, I mean, essentially all this is telling us that there's a lot of stuff that goes on which is not necessarily to do with the actual envelope circuit. It's to do with how you build a module in the first place. This decoupling, this smoothing of voltages, fuses, stopping low frequency fluctuations, that kind of thing. We should get the hang of that by the time we get to the end of this malarkey. Don't put them down your trousers. That's a good fella. So, we'll get past here. See what it says. Before you start, we highly recommend printing out the following bits. I haven't done that. And also, we've moved the printer, which is fabulous. I've got the printer out of the shed. I hate printers. Just, you know, unreasonably to the point of unreasonableness do I hate printers. I have broken printers in the past. I have literally thrown them out of the door and jumped up and down on them. So taking the printer out of my shed, I feel is almost like taking an evil presence out of my workspace and putting it somewhere else. So it's now in the house because actually every time we print something, it's usually the kids printing something or my wife printing notes for school. So I've got rid of it, but all that means is that I can't just quickly print something because that will never happen because it's a printer. I'll go to print and it will go, oh, I don't know. Is there a printer? I don't really know. Not sure. And then I'll have to spend the next half an hour messing about. So we won't do that, but it's probably a good idea. We're just going to stick straight with what we see. So we have these diagrams here. Now, why is there two? Okay, see, this is interesting. I don't think we've seen this before, but we've got, what are we currently looking at? Are you looking at the overhead? No, you're looking at the manual. Good, good. So we've got this, he's got these two views of the board. We've got our front panel, which is fine. Don't need to worry about that. That matches up. No mysterious holes in that. We can look at that in a bit. But our PCB has got a lot more detail on it. On one side we've got the numbers for different things, But on this second panel, we have the names and the values of everything, which is great. I love that amount of detail. That's fantastic. So I don't think we're going to get anything in the wrong place this time. Excellent. Also, looking at this, I think it's all on the PCB, more or less. Where are my specs? Yeah, you've got both the numbers and the values on the board itself. So we are well looked after for this build. Well looked after. Great. It's just the hardware that goes on the other side. Good. All right, this is good so far. Feeling positive. So, okay, place the envelope, PCB, in a PCB holder, which I don't have, and I continually don't have, because I'm just trying to emulate what people don't have at home, you know. Or simply on top of some spacers. Yeah, I do have, possibly, anyway, we won't worry about that for now. So he's saying, put on all of the resistors and the diodes on this page. Cool, I'll just check the text. I usually start by populating with the lowest horizontally placed components first, in this case resistors, switching diodes, power protection diodes. Bend the resistor leads and insert them into the relevant places. All components of PCB have their value denomination on the silk screen. If you're not sure, use a multimeter to check. Next, insert the diodes. Remember the orientation. Flip it over. Solder. Good, yeah, we're going to do exactly that. That's exactly what we're going to do. I'm going to bring that up as a little bit of a guide. I'm going to switch this. Okay, I've got it written down and I still can't convince myself. So here we are, overhead. Right, good. Stop running on and let's have a look, see what we can put in here. So we're just going to sort of start at the top up here and work our way down, and we're looking for resistors and the like. So at the top is a great big fat one of these, because this is next to the power switch. Can't get them out. So these are the stocky diodes. And you need to make sure it's the right way around on there. These are good and thick. Stick those in. They might need a tug. And next to that is a 10 ohm resistor, which are in my pack are these brownie ones, which is cool. We measured these all on the multimeter yesterday, in case you're wondering. And then I labelled them up. So there's another 10 over here. Like so, and the other diode, big fat diode, make sure it goes the right way around. Line against line. Like that. Good, great stuff. Now next to it is a 470. I think I used a 470 on the board. So more 470. So I'm going to have to go back a few pages. We got to one with a status LED. So we're doing power. And stuff. 12 volts. This is the gate input. Whereas I'm talking about the status LED, which is in the middle. Oh yeah. There, so that's why there's the 470 right next to it, because that's the LED. Okay, so that's the 470. The 470 is over here. And go straight in there. Good, great. Sound like I know what I'm doing, don't I? Right, so 470 over there. There's also a stand-up resistor that we mustn't forget about. So there's a 47k. The 47k was down here, next to that, yeah, that fella there, 47k. And then 100k, got a couple of those left. But there's also, I'm going to take them from here, that's a 10k, that's a 100k. Come on, tidy it up, tidy it up. So there's a stand-up 100k there, mustn't forget, mustn't forget, must not forget. There's a little diode over there, little diode. Really?
Call from Mum and Dad V.
Oh, it's my mum. Awesome. Hi mum, thanks for that. I thought you always said you watched me on the telly. Or maybe I'm doing something wrong. Oh my goodness. Okay, 100k's, 100k's. I need a 10k. Now that 10k is this long one here. Yep, for R4. Then got a couple more of the diodes. VD4, one there. And VD8. I'm going to check this again with the photo in the manual once I've placed everything. Okay, coming down, there's a couple of resistors which are stand-up ones, which we'll do later. There's another diode, VD9. Then 100 ohm. Did I use 100 ohm in there anywhere? 100k, 100k. Don't think I did, in which case that should be this one. It's got 100 written on it. Yeah, let's go with that. Ohm. 100k. Do I have any more 100ks on here? That's a 1k. What are these two? One's a mystery one. So what's that? Oh, I don't know. Where did that come from? See, that's got me worried now. I haven't got this upside down, have I? No, that's the LED over there. So what's that? I'm sure we'll work it out. But this one here is 100k. That's slightly strange. Alright, don't get stranged out by it. That's 100k, looks like the other ones, yeah. 2 more 100ks down there. So what is that? It's another 100k. I must have left it somehow. Don't overthink it. Don't overthink it. Alright, okay, so there's 100k. There. And then I've still got a couple more to go. I mean, all of this is going to go on here, right? Isn't it? There's only the one PCB. But I do have a bunch of those upright resistors. 100k, 100k, 1k, 100k, 1k. So I've got 100k here along the bottom. I think I'm just going to go all the way. I mean, you know, I'd normally perhaps start soldering at this point, but I'm going to put them all in. 1k and 1k. Now that should be that one. I should have another one. Yes! Yes, 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 yes. One K. Okay. In between, I've got a pair of these fellas, diodes, one that way up, and then this other one. Goes facing down. Good, good. What's left? So I have 1, 2, 3, 4, 5 resistors in terms of this batch of bits, and I've got space for 1, 2, 3, 4, 5. Good, lovely, right. We best do some soldering then, hadn't we? Getting a bit closer. Oh, where's my pot gone? Oh, over there. So, safety specs. Got to put on a little bit of air to blow away the dangerous fumes. Where's my pokey thing? A bit of that to poke at things. Looks all right. My these don't seem very good. Do I have something more than my t-shirt? No, I don't think I do. That's a bit better. Right, solder, ready for this. So, doesn't really matter what order you solder anything in, just whatever you can access. Obviously you can have this in some kind of holder in a posh way, or you can just sit it upside down and push it around with the hot end of your soldering iron. That's all we're attempting to do. The long legs on these diodes might take a little bit longer to heat up, but otherwise, put the thing on, heat it up, try to present it with some solder, patience, try angling it slightly differently if it takes a little bit too long. I shouldn't have started with the big thick leg. There you go, it's starting to melt, starting to melt. Yeah, a bit like that. That's how you do it. That's how you do it, he says, like as if he's some kind of bleeding expert, which is pretty obvious that I'm not. But I'm a goer, I'm a doer, I'm a trier. That's the word. I like to, you know, I like many things, but in this I like to push the solder on, take the solder off, sort of put my finger on the board as I take off the heat. These normal legs here are just like butter, just lovely. I love the way solder moves, it's just an amazing thing. I mean, who came up with all this stuff? I'm sure I'm about to be educated by my lovely people in the chat that say, oh yeah, soldering was invented by Mr. Solder, 1463. That kind of thing. Cool. Oops. When there are lots of legs knocking about, they do get in the way. Of course they do. So it sometimes makes sense to like put 10 things on the board and then solder them, so that way you're not getting in any way of yourself. I've just gone for the whole lot. That's just the kind of person I am. No, well, I don't know, it's the sort of person I am for the minute. I mean, you know, wouldn't exactly say I'm defined by just throwing things in there. Try not to put the solder directly onto the iron, because it then doesn't go on to the pad. Sometimes it does, but often it doesn't. But also I find that pushing the solder kind of onto the end a little bit, it just kind of gets it going, particularly on these thicker bits, because I'm always that little bit impatient. Is that all still on the screen? Good, good. There's also nothing to stop you from pausing, cutting a load of legs off that you've done, and then continuing on. You know, it really is up to you. Don't be conned into thinking, or fooled into thinking, that there's a one particular way of tackling it. As long as you're getting solder onto those joints, that's all that matters. That's not very good. Have I done a way up there? Yeah. Okay, turn this around a bit like this. Start at this end. Now see, the end of my soldering iron has got a little bit too much stuff on it, and I can jam it in my weird steel wool thing over here. Will help. Also a little bit of water might help. Those things just sort of clean the ends off, which ensures that you are getting a good contact, good heat transference, good soldering. And there you go, I've just put solder all the way straight back up the iron again. Awesome. Okay, still seeing all of this? Good, good. Now I haven't done this particularly methodically, so there's bound to be little missing bits. Oh come on, that's the last one! Come on, sort it out, sort it out. That, I think, is the lot. I'm going to have a closer look. Weird weather today, it's got it raining again. We've had strange storms, sudden squalls, sunshine. We've had everything today. It's been bizarre. Okay, look, I missed a hole there. It started raining again. I can feel it in my bones, or rather, hear it on the roof. You know what I didn't do that I'd say I was going to do? I was going to compare it to the picture. Well, let me do that before I cut the legs off. Right, this picture here. So, this way up. So I've got diode, brown resistor, ground, brown and green, diode, green, blue. Don't ever go on the colour. Now there's another blue one there that I appear to have missed. That's interesting. And there isn't a diode there. Wow, okay. That's just awesome. Don't panic. Think about it in a second. Let's look through the others. That's good, that's good. Yep, yep, yep. Yep, yep, yep. That's good. So something weird and crazy going on here. Now that's a version 1 board. This is a version 2 board. So I can make the assumption that there is the possibility of something changing. Let's go up to the one above here. See if this is any different. This doesn't have any. That's a completely different board. In fact, that's a completely different module. Don't look at that one. That picture is of a completely different module. It's this one that we need to be worried about. So this is important because this says here that that's version 1, and this, as you can see on here, is version 2. So there has been a slight change. Now the change that I can see is over on here. You can see this. See, I've got a resistor and a diode, whereas on the image we've got a diode there across the top above that capacitor, which is not on here. There's the capacitor there, the other capacitor, small capacitor. There's the film capacitor. I've got A, which is a test point. That's definitely my diode. That's definitely the resistor R4. So what resistor is not there? R8. Where's R8 gone? R7, R9, R10, 6, 19, 5, okay, this is interesting. There's no resistors on this side, is there? Sneaking on. Right, so just have a look up at the schematic. I think this is just a change, we don't need to worry about it, but I'm just going to go through the process of checking just to see if we can spot R8 on here. I'll swap this over for a second. So 7, 9, 4, 3, 10, 11, 12, 14, 13, 1, 2, 14, 16, 20, 21, 18, 19. Right. So there's no R8. Going to check if there's any mention of that. R5 and 6, R5 and 6, ferrite bead. Talking about that. No. All right. So I think through the process of looking at things closely, we can decide that the R8 on the picture on here is from the earlier revision of the board and is not something we need to worry about. So this section here is actually correct. That's what I'm going with. So that's a little bit of drama for you. Drama's always good. I'm going with what I've got. So I've soldered it all. Now I need to cut all the bits off. Then we can move on to the next stage. Decent pair of cutters was definitely a worthwhile purchase. They don't have to cost a huge amount of money. I mean, taking my kid to my older child. He's doing Duke of Edinburgh Silver, right? This is relevant, I promise. And do I have the right thing up? Yes, I do. And what was I saying? Oh yeah, and Warhammer Games Workshop do supervised Duke of Edinburgh sort of skill part, the skill part of Duke of Edinburgh. Are you with me? The idea being that you can paint a whole and build and paint a whole army, which is fantastic. So my Alfie's into that, which is cool. I quite like it too, and has enrolled to do that as his Duke of Edinburgh Silver. And I drop him off at the Warhammer place in Norwich on a Wednesday, which is where I was yesterday, getting late to be here. Why am I telling this story? There was a reason. I'm trying to remember what that was. Oh yeah, and one of the things is that they have to use, they're only allowed to use Games Workshop tools. You can't use third-party ones or paints or glues. It all has to come from the Games Workshop because, as they say, that invalidates their insurance otherwise, or some such nonsense. But what that means is that you then go and have to buy the proper bits and pieces, and a pair of clippers. I got an old pair of clippers in the original Battle for Skull Pass that I bought like 10 years ago, 15 years ago, when I fancied having a bit of a Warhammer go. And it came with these clippers, which were a bit kind of crappy, but I used them and they were proper. But they sort of laughed at them when Alfie turned up with them, saying, "Cool, they ought to be in a museum, mate." You know, that sort of lively banter that you get between nerds. So we had to then buy a proper pair, and you know, they're nice and everything, but they're like 20 quid. 20 quid for a little pair of snippers that got Warhammer or Games Workshop written on it. God, it's just flipping heck. Whereas these, I think these might have come from Thonk. Might have done. They're good, do the job, and I'm sure they didn't cost that much. But it's worthwhile getting something for the purpose of what you're doing. Anyway, that's slight diversion. Moving on. Next, dip sockets. Do you want to do dip sockets? And it looks like capacitors also. The little mini capacitors. So the sockets and the capacitors. Is there anything else which is going to be less than that? Let's stick one of these in and have a look. So these go in here. Let's stick in one of these to see how they fit next to each other. Yeah, the capacitors are slightly taller, so I'm going to do the dip sockets first by themselves. Otherwise, things end up falling out. So you've got 3 sockets that the chips go into. You've got to make sure that they are the right way around. There's a little nick. Do you see that? A little indentation on there, which should correspond to the same sort of thing on the IC holder, which then corresponds to the dot on the actual IC. Now you can sort of pull a little bit on a leg and it will more or less stay in there. Sometimes. Maybe not. Otherwise you're going to turn it over and the whole lot's going to fall out rather. Now I've got a little sheet of plastic which I've moved. What's going on? What was that? That I generally use all the time, that I always keep handy, that I seem to have put somewhere. So for stuff like this, what I do, I put a little thing over the top, like so, hold it flat, and then turn it over, put it down. Sometimes I slide it out, sometimes I just let it hang in there. And now I have those sockets upside down, perfectly flat, ready for soldering. Yeah, you can also use tape, blue tack, sticky gum, whatever you like. I've got 3 lots of these. Just going to whack them in, I think. So I'll put one leg in on each. I'm going to hold it down flat before I take off the soldering iron, just to give it the best chance of being nicely flat. Obviously mind your finger. Pushing down quite firmly also helps with that. With the soldering iron, I mean. So that should have tagged in all 3. Yeah, they look fairly flat to me. One more check on the nodules. The notches are all in the right place. Yes, they are. Good. I will solder the rest of that in then. Good. Going chunky on the solder tonight, so it seems. So that's all of those. Next we need to do these little bobble capacitors, whatever they're called. What are they called? There's a name for them. 104s? I don't know. Are you talking about Dragon 64s from Tandy? Good lord. Well, as long as you keep yourself entertained, that's the main thing. So yeah, one goes in there. So over here we're looking for these capacitor signs, yeah? 0.1 microfarad. These are not electrolytic, they don't have a polarity, they just go in any old way. Like so. There's one there. 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 See, this is coming together nice and quick. I reckon we could be out of here by 10. Dare I say 9:30? Past 8? Is that all of them? Yep. Does it look like that? One there, one over here, one over there. One there, and there. Yeah, good. That's a good one. Turn it upside down. Solder. Now you realise there's two of these kits, right? I wasn't planning on soldering both, you'll be pleased to hear, but I will have them ready for next time. The reason there's two is because you want one for the oscillator through the VCA, and you want the other one for the filter, which we've yet to build. I wonder how we're going to be triggering both. Oh wow, that was a right mess. Did you see that? That's just awful. That's better. Solder going to jump off for me. Looks good. Envelopes are one of those things that I struggle a lot with. It's like in a synthesizer, any old synthesizer, you have your filter and you have an envelope going to it, and I can always make those sound fantastic. I can make it sound fantastic on a software synthesizer. No problem. Feeding into the filter, doing all sorts of crazy stuff. Lovely. In modular, I find, for some reason, I find it much harder to get the sound that I'm after. That, I suppose, that acidy filter envelope sound. I don't know what it is. Is it the type of filters? Is it the connection? You know, you end up with these so many parameters. So you've got the shape of the envelope to start with. You then got the sort of attenuation of how much envelope is going to your filter cutoff. And then you've got the cutoff setting in the first place. You've got all these things sort of working together. to try to produce a simple squelchy bass line. Always seems a bit too tricky to me. But you know, I get there. I do alright. So those are in. That's good. What's next up? In order to save space, they have some vertically placed resistors. Yes, indeed. Good. I'm glad they talked about these. Next is to put those in. Bend the leg. That's good. So there should be 5 of these, I believe. So I have 5 resistors left. Here we go. And I've got to bend these weirdly. Bend them weirdly. Is it me that's weird, or is it the bending that's weird? Okay. Oh, I've got a cramp in my fingers already. Ouch. Come on, fingers. Sort it out. So, on here, other way up. There is one here. See the circle on the PCB? That's where you want the base of your resistor to be. So it goes through there like so. Bend it underneath. There's one there. One there going that way. There's one next to it. And these other 2 face them. Oh no, one goes down that way. Doesn't really matter actually, the orientation of resistors is completely unimportant. But that is like that. Interestingly, that's quite upsetting, that one. The fact that those are opposite each other and these 2 are the same. Gracious me, what are they thinking? So let me just check that we're in the right ballpark. Yeah, that's what he's done there, and one up there. Excellent, let's solder those in. Yeah, cut them off. Good, so it should look like this. I think it does. Great, next up. Next, insert and solder the electrolytic capacitors. These are bipolar, need to mind their orientation. These are these fellas here. So It is, as always, long leg positive. Long leg positive. Now we've got two spaces to put these on the board here. And according to the PCB, I think this line is for negative. The positive lead of the electrolytic capacitor is longer. There's a minor stripe on the side of the capacitor's body to indicate the negative. On our PCBs, the positive pad for the capacitor has a square shape, and the negative should go into the pad next to the notch on the silk screen. So this notch here, this line here, is referring it to the negative, and the square is for positive. So long leg positive, long leg goes into there. Now I get the feeling we might want to put this on at the same time, if not sooner. Or does it go on the other side? Because this is going to be, these are going to be taller than that. Let's just check. Yeah, so let's put in the power socket first, if that's okay. Look, I've also got the transistor to go in. Did it mention that? Or was it here? Inserting and soldering the transistor. So yeah, I'm not going to put in these quite yet, just simply because they're tall and far taller than other things. So let's take our transistor out of our board. That is going to go into this 3-prong hole here. It's the only place for that. It goes in the same orientation as it is on the PCB, so you can see. Just sort of shape the legs into a 3, so there's the middle one sticking out, and that's the flat side. That goes in there. Cool, that's relatively harmless, that one, so I'm going to leave that in. Then I'm going to put this fella in. Now there's a corner taken out of that. I don't really know what that refers to, because this could go round either way, but I'm inclined to think that this bit, I don't know what I'm inclined to think. Give me a picture. Alright, see, I probably would have naturally done it the other way round, but the picture says that the notch goes in. So from that I'm going to assume that this notch here refers to that corner notch. Yeah, like that I think. That's what I'm going to go with. Now I'm just going to see if I can just turn it upside down and go with that, which I can. I've got a spare bit of foam knocking around. I'm just going to leave that underneath just so it's a little bit flat. I'm going to solder those two things and then do the capacitors. Yeah, that's in, that's flat. I'm going to go with that. All good. And this transistor. Try one a little bit more. Yep, good. Now I can put these electrolytics in. There's nothing else in the way. So long leg positive into the square hole, negative side against the line that's on the board. Lovely. this one, long leg positive into the square, negative against that line. Simple. I think we're done with the PCB. So you've still got the hardware to stick on the front, but we have done, oops, it's on setting, I'm accidentally heating up something else. This is all really straightforward so far. We had a little bit of a slight bit of doubt over board revision and the movement or the removal of a resistor. I just bridged that. Look at that. What a nightmare. Oh no, I've saved it. Too much solder on the end of my what's it. So I ended up dragging solder from one leg to the other, like I just almost did it again. Looking great, looking super smashing. No obvious terribleness. Oh yeah, no, there are some obvious terribleness. I haven't put these in. Rats, there's always something, isn't there? So these film capacitors, there's one there, like so. Gonna bend those, ouch, so it doesn't fall out when I turn it over. And there's one there, and there should be another one. Oh no, it says optional, so let's not put that one in there then. Let's just put this in here. These are both the same, yes they are. So I should have ideally put those in before the electrolytics again, because they're slightly smaller, but their legs are holding on. They'll be just fine. Just fine. Come on, what's up with you? What's optional about the capacitor, asked Neil. What a good question. Let's have a look. See if there's anything in here that will tell us about that. Let's go back to the, oops, the bit at the top here. These are capacitors C10, C11 and C1, C2 to C5. Okay, capacitors C6 to C13 are additional decoupling capacitors. Their job is to simply compensate for unwanted noise. Typically 0.1 microfarads are used. Yeah, but those are the beady ones, not 10 and 11. It doesn't actually mention it. So let's see where it is on here. Yeah, it's part of what reduces or stops it coming back. Stops the negative voltage is what it does. So maybe there's an optional one just to make that smarter, quicker. sharper. It doubles the attack and release time. There we go. So it takes longer, I suppose. If there's two of them, it takes longer to fill, and so that gives you that longer time. Exactly. What? What? Rumble Bob the Builder? What? See page 51? Oh, okay. Doop-doo, doop-doo, doop-doo. Doo-doo-doo. Oh! 51. 51. Congratulations! You know, I don't think we should have jumped to the congratulations bit. That seems a little bit ahead of ourselves. You can install an optional C11, not included, damn it, for slower drone music. There we go. We'll double the attack and release time. Excellent. Good question, Neil. Look at that. We found the answer. And Rumble Fluff even shouted my name, which was quite alarming. So, let's see where we are. We were here. That's all completed. Power socket on. That's all on. Got the films on. Got the switches in. Haven't put in the chips yet. Then complete the component side of the envelope by soldering the PSU socket. Yeah, make sure the orientation is with the arrow on the first pin and the notch of the silk screen to the key of the socket. Got all that? Facing inward. Should look like this. Now turn it round and inspect your solder joints. You go, oh my goodness. It's probably the most accurate thing at that point. Make sure they're all soldered properly. Well, I don't know. I'd need to hand it to an adult, I think, to work that out. There are no cold shoulders. Accidental shorts. Clean it with weird flux cleaner if you have such a thing. I do not. I'm just going to check for bridges, as that did happen. By a bridge I mean where two things that have been soldered next to each other have embraced each other with solder. It doesn't appear to have happened. That looks alright. That's good. Insert the jack sockets and solder them. So on this front end we've got, you see you've got 3 legs, and you see you've got 3 holes here, 1 and then 2, 3. So the best way to put them in, so you've got the board this way around now, there are your components on the other side, this way around now. You plug that in like that. You sort of push it against this end one, and then it just sort of holds itself in quite nicely. Do it again, like that. Third one is up in this top corner, that way around. Good. Now I've done this thing before where I tend to put the front panel on when I solder jack sockets, just to make sure that they don't wander. So I think I might do that, because I can sometimes, you know, install things that are a bit skew with, and then they don't fit in quite so well afterwards. So I'm putting just the front panel on, and I'm going to stick a nut on. I think this might be a bit over the top perhaps, but I'll just turn it over and do it. But this just makes sense to me. It just means that I'm less likely to solder them at a wobble. And it doesn't take me a minute to take them off again. So I think it's a good rule of thumb. Just to do that. Turn it over smartly. They should all be good. No, help is good, mate. Help is good. I appreciate it. I appreciate it. I also appreciate the slight delay we have between ourselves, which we have learned to live with. One socket. 2 sockets. Oh, the other one's right up here. Cool. Jack sockets in the pots, but don't solder them. Okay, so now we're going to do the same, probably. Oh, don't lose that, as I did here. So pots. Now I've bent all the legs of the pots in order to get them into my breadboard, so I need these sort of smartly back that way. What's up with my fingers today? Yeah, I'm just falling apart. Cramping up. So push those down. Good. So, what? So, which way up? It will probably say, won't it? 1M, 100k. So that's a 1M. That's going to go over here. Give it a nice firm push in. This is, that's 100k, so this is the extra 1M for decay release. This one's a bit wobbly, a bit off. There we go. Good. This last one, which is the 100k, down the bottom. Like that. Good. Fit the front panel to make sure the shafts are aligned. You see, I did that with the jack sockets too. Maybe I'm just too careful. That's definitely what you see me as, I'm sure. Yeah, he's overly cautious, that guy. Yeah, he always take the right amount of preparation. He always double reads the manual. Always using the right tools, that guy. That's what they say about me. Most definitely. Alright, those are on. Freely rotate. Yep, all good. Smashing. Solder those. Go ahead and solder. Yeah, good. Now this might fall over because they're a bit hanging out in the middle. I've never been 100% sure about these great big fat lugs, whether you're supposed to solder those in or not. Because I've seen on some bits of gear that I've received that they're not. They're really just sort of there for stability. But it seems to make sense to me to secure that stability with a great big wob of, oh, don't melt things, of solder. It does use a lot though. Oh, there you go. Falls over. Try not to melt the big creamy things. It's very satisfying. Oh, when it goes all the way around. Turn this around, I think. Good. 1, 2, 3. That one, that one, that one, and that one. All good. Single loop switch. Switch widths. Requires special attention. Okie dokie. There are 2 nuts. They look identical to jack nuts, but the thread is different. Oh. Well, I've just kind of stuck them on. Oh, do you mean the thread on this is different? Not that this is different. Not that the thread on the... They look identical to the jack socket nuts, but the thread is different. Okay. How do I identify that they're different? I would say these 2 here are slightly different. Wow. I had never noticed that before. Now, is there any way that you can see that those are slightly different? I don't know that you can. Oh look, the edge. You see the edge? It's different. This one is slightly squashed. So the squashed ones are for the patch sockets, because there's 3 of those. And the slightly, very slightly thicker ones are for the switch, is what I'm saying. Screw one of the nuts on until it fixes itself to the bottom of the thread, so it needs one on there to start with, to make it the right height. Good. So now put it in the place where it's supposed to be. Doesn't matter which way round. I do not think so. Put on the front panel. And fix it with the other 3 nuts, of course. Now I've got to get in there without melting the power socket. Ooh, see, very nearly. In fact, I think I might have done a little bit. It's spinning. I think I got it. Got away with it. Got away with it. Now I think we might be. I think we might be there. I think I can just put this nut on here, and it's a good one. No, wait. There's a hole here for the LED. So just hold you on a second. Put the... Okay, so check the silk screen. So we've got the LED. We have to put this in. We can't. Oh, that's a real pain. I could have put that in last time, right? With the leather thing. Because that's not going in there, is it? I've got to take the front panel off again. Oh. So, that's a drag. That's a drag. Come on. See, I could have snuck that in there before I put the switch on. No one would have minded. Just so that it was there. So, here we go. Here it is. This one here. Now these, throughout all of these projects, the LEDs have been quite troublesome because, you know, it's supposed to have like a flat side on it, and that's often obscured by the actual holes for the legs. And I know that they've said that the square is positive, but I've also had PCBs where that's the other way around. I've also had PCBs where they're both in both directions. So I have my, I don't like to rely on the squareness of that pad to denote which way around it is. However, that seems to be the case. So the shorter lead goes to the notch. The longer lead is to go into the hole with a square like on it. Okay, so long lead, longer, it's only just about longer. So longer goes into the top, shorter goes into the bottom, where the flat part of this LED is a flat part. Just about, you can sense that it's flat on this side of that circle, yeah? So that goes down. Then we don't want to solder it because it needs to come up into the front panel. So now I think we can put the front panel on. Is there anything else? Sockets, and then we're done. Yeah, good. So we're there. We're there. What time is it? 9 o'clock. Excellent. Excellent. So we'll get a chance to test. So this goes back on. Now we can put our screws on. This should be the last time. There'll be a resistor going to the positive. Thanks for that, Ken. Yeah, I think it was a bit clearer this time, so I didn't need to resort to actually knowing what I was doing. But we'll soon find out when we turn the thing on. So in order to do the LED, which is going to be tricky in there to solder, I just sort of wiggle it through till it's sticking out. You could, if you wanted, just hold it back a little bit if you're into kind of flushness of these things, or you can just have it sticking its head straight through. You can get LEDs that have got flat tops that look really nice, flush against the front panel. This is not such a thing, so I'm going to go with it sticking all the way through, I think, in like a bit of an old school style. And then I've somehow got to get me jolly old soldering iron in here. Maybe. Yeah, could be. Could be. I'm not going to cut that exactly to the bottom, just going to keep it out of the way, so I can't get to it with my clippers. Not going to worry about that too much. You've ground the top off round ones. That's a little bit extreme, but yeah, fair enough. But yeah, this is old school sticking outy type LEDs. Good. Right, did all of that. Almost done, it says. Now put the icks in the dip sockets. So these are all three of these are the same. So we haven't got to worry too hard about that. They're just op amps in this little Texas Instruments TL072CP. So the dot goes where the little nick is. The nick or the notch, whatever it is you call it in your parlance. So it goes there. So this needs to go that way around. Nice. And this one goes the opposite. Dot goes into the middle, doesn't fall over, just like that. Of course you shouldn't handle them or touch the legs in any way. In fact, you should ideally do this underwater. That's going in that way, goes in, lovely. I reckon that's a good one. I reckon that's done that. I reckon that's alright. I reckon that's good. Yeah. Congratulations, you've completed the assembly of the envelope module. The envelope does not need any calibration. Hooray! Doesn't need calibration. Right, good. I can get rid of these glasses then, and put that over there. Good. Calm down. I'm even going to turn the soldering iron off. I'm so confident that it's just going to flip in work. No calibration. Well, that's what I like. That is just brilliant. So connect the power supply. We got one of these. This can only go one way round, which is like that, and the red line, just about red line, should go on the minus -12. It says there -12, but as I say, it can only go one way round because of this notch, but it's just worth checking that last time before you plug it in that that's correct. So I'm going to need something to make this happen, aren't I? Flip the switch to loop mode, check the LED is blinking, oh yeah, and then adjust things. If you want it slow, add another capacitor, which will double the attack and release time. That is it. That is it. That is it. Soldering appendix, yep. That's all good. Right, well I should... no smoke please. Well, I don't know. Not for me to say, I don't think. So let's wind this the other way, back up. Now this is what we had from yesterday. Now to test this, I'm not going to use an LFO. I'm going to get a keyboard with a CV out. I'm going to go my key step, I think. Ugh, which means I've got to take this out because I think an envelope might need to go nearby. I don't really know. We'll have a look. I need a screwdriver. The screw threads on this case are not really particularly great for knurlies. They're just a little bit tight. In fact, I would even be tempted to say that they are slightly wrong sized for these knurlies. But I can't tell you what size I have off the top of my head, and whether I've got ones are too thick or too small or whatever. So you might find that other screws would go in better. It's not plugged in, no. Just get rid of that for now. So this, do we think that's going to go right next to? No, it's not going to go there. No, not going to go there. Could fit there. Or right at the end. There's no an output module. See, these three are the same, so I reckon that could probably go there. I think so, and the other one next to it. I think that might be the answer. Oh, well look, there's nowhere to plug it in, so I'll have to feed this one through. Can't see all of this that I'm doing. Put that through, turn it around. Could of course take the filter out and do this properly. I'm just going to do it. Do it. Right, there we go. So that's going to go there. I'm just going to put a screw in. After all saying all that they don't really work. I'll put them in anyway, just to secure it a tiny bit. They kind of find their own thread, tap their way in as it were. Right, power is here. So, smoke test, as they say. Look at that lovely, lovely pulsing LED. Look at that. How fabulous is that? Pretty fabulous, I think you'll find. Right, so we're just going to take the output, plug that into the FM input. Nice. So what happens if I take the inverted output, plug that into the other FM input? Is that going to make the whole thing just implode? Or just do nothing? Rock and roll. Nice. Right, I need power for this thing. Power for this thing. Anyone got any power for this thing? Power. That'll do. No, that's two different cables. There we go. Got a little bit of that in shot, you'll just have to take my word for it. So I want to gate the envelope and play the pitch. So that's 1 volt per octave. Pitch. Sorry, getting carried away, and I need something that's a really long one. That's a little bit less long. I need gate to go into gate over here. broke it. Doesn't like the gate output from the arpeggiator. Let's see if I can bring the gate size down. Doesn't want it. Interesting. Okay, let's see if we can get something out of this sustain business, see if we can detect a difference. So let's give us a long release. So I've got no sustain in there at all, so it's just going attack and then decaying. Slightly strange things going on. That's okay, I don't mind strange things. So if we bring the sustain up to half. Then it does it does that little bit later. This is probably something to do with my compensation on here. Might be a factor. If I turn that all the way up. And then there's a release. That's better. Yeah, I had the compensation on the filter was sort of beefing up the signal a bit, and that made that not quite sound exactly as we thought it should sound. Remember, we're talking about the filter being affected by the envelope, not the VCA. So I then put the sustain all the way up. It holds it. And then releases. Yeah, see, sustain is definitely doing something. If I turn the sustain all the way down, it just cycles straight through the decay. Yeah, got it. Fantastic. So this is our pseudo ADSR. When really that's all I've ever wanted. So you either have the decay come back after it's gated, or we turn the sustain down and it happens straight away on like a trigger. It's funny how I find the key step doesn't always kick out what it's supposed to first time. I don't know if anybody else finds that. Ooh, nice. Is that to do with my tuning and calibration on the VCO, do you think? Nice. So let's take that out of there and stick it in to our VCA instead. Oh, I could take the inverse out, couldn't I? Use that. No, I don't have a delay to hand, sorry. What do you mean? I'm not... Oh. Thank you, that's lovely. Thank you for that. I'm not using it to extend the decay. It's that what happens is, I mean, if you weren't, were you here last time, NTO Steve? So it's not an ADSR, it's a pseudo ADSR. So what you're getting is that a sustain level is put in there that the decay does come down to, which makes it act like an ADSR, because it sort of does. It's just not, it doesn't have a separate stage for the decay and the release. So no, it's doing exactly what it's supposed to do. I'm not doing anything weird with it. I don't think. What's that going to now? That's going to that. So that's a load of rubbish, isn't it? So why am I getting that sort of doubling effect? Oh, because I got hold on? No? Got it on single, that's loop, this is single. Okay. Think about it, think about it. Is there anything to think about? There's sustain, I'm holding it on, yeah? And then there's my release. You'd let it decay, don't I? In order to let the attack come back in. My old VCO probably needs a little bit of work. Yeah, with a long attack, you don't get... It doesn't have time. Was there something about it having time to get to the sustain bit? It doesn't go up and then back again if the attack's too long. So in order to use a longer attack, you need to put the sustain all the way up. You can use a short attack without any sustain. Gate length from the controller. Yeah, but that was during the arpeggiator. At the moment, it's depending on how long I hold. During the arpeg, had it on 10%. That's 90%. It's not really making any difference unless I put the sustain up. Then if I put that back down to 10%, yeah, getting it. 50%. 90%. Rebel Fluff, I've just explained that, I think. But of course the gate length doesn't matter if you've got sustain off. Anyway, there we go. I think that'll probably do us, because it's 9:30. That's 2 hours. That's a good round trip, that is. Now there's a whole other one. I've got a whole other one here to build. I can start on that now if you like. Do you fancy? Or we can call it a night. I think we'll call it a night. Of course, you know that I'm going to be making this one about half an hour before the next live stream of the next module in order to get it finished. But no, I will finish this at some point. I most definitely will. But that was good. That was good. I enjoyed, because as I say, envelopes are this strange thing that boggles my mind most of the time, and yet they're such great fun when you I don't know, merge into it. When you get the hang of it, envelopes are brilliant. I'm forever seem to be searching for just a simple, fast, quick, enjoyable envelope, and they seem to be hard things to find. They tend to be massively complex or overwhelming. And I got that wonderful one from This Is Not Rocket Science, but it's awesome, but it's not really what I'm after. It's a massive thing for a single envelope doing its thing, you know. And then you got, I mean, I've got my dual Erica Synths one, but even that's a little bit over the top. Too many options. Whereas this is great. I just kind of want it in 4 HP. And 2 of them, which are separate and normalized. And I'd be a happy bunny. Be a happy bunny. Thanks, Pete. Great. No, what's next is the sequencer. Sequencer is next, apparently, 28th of April. I probably shouldn't have told you. I don't think it matters at this point. But that's my understanding from Erica Synths. That is the one at the end of the month. So we will pick this up in 4 weeks' time, I imagine, roughly speaking. But of course, I'll stick a YouTube link up as soon as I've booked a time for us to do it. Sequencer is going to be interesting. Lots of LEDs, I imagine, and also learning about how they work. Is it going to be quantized? Don't know. Is it just going to be any old pitches? In some ways, I hope there'll be any old pitches because my VCO is far from calibrated. That'll save me the blushes of that, I think. So, cool. So now we have a VCA dual, and a dual envelope. That's very exciting. I've borrowed a filter from Wavephonics, but I'm sure the filter will be along before we know it. Good. So there we go. Thanks for staying around. Thanks for coming along and having a look. Sorry I didn't tell more people about it initially, but it was a relatively easy solder. A few things to get around in terms of possibly melting stuff. As I mentioned, in the manual, the board, the PCB in there is revision 1, and in your box it should be revision 2, which moves or loses one of the resistors mysteriously. Don't worry about it. Just trust what's written on the PCB and you'll be fine. And there's no parts left over, so that's always a good sign. So good, great. Any last minute questions or things? I can think of an envelope generator as a 3-step sequencer. I suppose you can. You're always using something for something else, aren't you? never satisfied or content with its original usage. You're always bending it into something else. No, fair enough. Fair enough. It's all just voltage, as they say. You're welcome. You're welcome, fella. You're very welcome. I'll keep slogging away at it. So, as I say, when the sequencer's out, I'll give you a shout and we'll get stuck into that one too. Otherwise, coming up, I'm going camping. next week, which is exciting. And I am almost poised to buy my plane ticket to Super Booth. We're planning to do that today. I'm going to do it tomorrow now. Now I don't know what I'm doing. So I am going to go. I'm going to go for a day, and I'm going to stay Saturday night, so it looks like. So that's the plan. So if you're around on Saturday in Super Booth, then do stop me just for a couple of minutes. Now, don't monopolise my whole day because I got things to see. But say hello by all means. Anything else? No, always good stuff coming along. I've got lots of nice videos in the making coming along soon. Yeah, so great stuff. Thanks for sticking around. Good. Nice one. Naff all else on the telly. Yeah, that'll do me. That'll do me. Thanks very much. So I will see you anon. And in the meantime, go and make some tunes. And I'm just going to not even look.